Okay, now let us continue the example on page 65. Now you have this cubic function which is y is equals to 2x cubed plus 3x squared minus 12x plus 7. And we have two aims. Aim number one, we need to find the coordinates of the stationary points of this cubic function. And the second aim, I need to use the second derivative test to determine the nature of these stationary points. So let us begin. Step number one, let us find the stationary points by letting dy dx to be equals to 0. So first we need to differentiate. Dy dx is equals to 6x squared plus 6x minus 12. And at stationary points, dy dx is equals to 0. Let me continue writing that. At stationary points, dy dx is equals to 0. And now I'm going to let this quadratic equation be equals to 0. I am sensitive to numbers. I wrote 6, 6 and 12, so I can divide everything by 6 to give us x squared plus x minus 2 is equals to 0. Factorizing, I am going to use the number 1 and the number 2. To get positive, my bigger number must be positive, smaller number must be negative, and therefore my x is equals to 1 or negative 2. X equals to negative 2. But I need to find the coordinates, so now let me find the y for each value of x. So I have substituted x equals to 1 into my y function, and I get 2 plus 3 minus 12, which is 5 minus 12, negative 7 plus 7, so y is equals to 0. So I have my first stationary point, 1, 0. And substituting x equals to negative 2 into my y function, I have y is equals to negative 16 plus 12x, plus 12 plus 24 plus 7. I'm going to get 27. Y is equals to 27. And therefore, my point will be negative 2, 27. So I have found my two stationary points. And now I can move on to my second aim. My second aim is to determine using the second derivative test. Oh my goodness, where's the page? Here. Using the second derivative test to determine the nature of this stationary point. So now let us use second derivative test, which means I need to find d2y dx squared. So I'm going to differentiate this function. Don't mix up. This is the function I need to differentiate. And I am going to get 12x plus 6. Now, at my first stationary point, which is 1, 0, I am going to find out what is d2y dx squared. So I'm going to substitute in my x using 1. And I can evaluate 12 plus 6 is 18. 18 is more than 0. So which means d2y dx squared is more than 0. Therefore, I can conclude that 1, 0 is you're right. It is a minimum point because the gradient is turning positive. So if I want to explain again, it will be gradient turning positive from negative to 0 to positive. Minimum point. And then let's move on to the next one. At negative 2, 27. Yes. At negative 2. Okay, I want the color. At negative 2, 27. d2y dx squared is going to be, yes, using that d2y dx squared function, substitute x to be negative 2. I am going to get negative 24 plus 6, which is negative 18. And this is less than 0. You have to state that this is less than 0. And therefore, you have made a conclusion that d2y dx squared is negative less than 0. I can conclude that negative 2, 27 is a maximum point. Explaining this again, the gradient is turning negative. Turning negative means it is from positive to 0 to become negative. It is turning negative. So this is a maximum point. Let me use decimals again to show you why our results are such. I have already keyed into decimals this function. We have two stationary points at x equals to negative 2 maximum, x equals to 1 minimum. And there you go. You have the correct answer, where if I were to sketch the whole graph out, you can also do so together with me. You have maximum at negative 2 and minimum when x equals to 1. This is just a very rough sketch, okay? This is my x-axis, this is negative 2, and this is my 1. Let's move on to the next example. The next question I'm going to do is on page 68. Mr. Ng will be recording the notes on page 66 and 67, explaining to you what happens when d2y dx squared is equals to 0. He will explain that to you. You will get to hear Mr. Ng's beautiful voice. Now let us move on to page 68. I'm on page 68 and this is the question I will be doing. And we have this function. We have to first look for dy dx for this function. Oh, this is not quadratic, not cubic. I have to make use of my differentiation rule, product rule in this case. Part 1. dy dx is equals to, I am going to keep my first function. Differentiate second function. This is power half, remember. I am going to bring down power reduced by 1, which is negative 2, and times differentiation of x plus 7, which is 1, so it doesn't matter. So over here I'll write plus, keep my second function, which is x plus 7 to the power of half, and times the differentiation of the first function, which is 1. So there we have it. I'm going to use factorization. X plus 7 to the power of negative half, and I have over here half of x minus 5 plus, over here I take out negative half, I'm going to be left with x plus 7 to the power of 1. And I can now simplify the whole expression. I'm going to first put this at the denominator because I have negative power. This is going to be the square root of x plus 7. And over here, I am going to have half x plus x is 3x over 2. And over here, I have minus 5 over 2 plus 7, which is going to give me 2.5 plus 7. Negative 2.5 plus 7. Well, when I think of money, it's the fastest to calculate. $7 minus $2.50. Yes, I get $4.50. So I have 4.5. 4.5 is equals to 9 over 2. And now I can very quickly write this without fraction in fraction. I can bring out the half and put the 2 of the half at the denominator. Half over here. Because if you were to bring out the half, you are going to get 3x plus 9. Then you bring this 2 to the front of the denominator. Okay, so far? So this is my answer for part 1. Now let's move on to part 2. I need to use my dy dx to find the coordinates of the stationary points. So I'm going to write again. At stationary points, we have dy dx is equals to 0. So 3x plus 9 whole thing over 2 root x plus 7 is equals to 0. Well, you can think of this as cross multiplying. Anything times 0 is 0. So you have 3x plus 9 is equals to 0. And therefore, I have my x is going to be negative 9 over 3x is equals to negative 3. Do I have to find the coordinates? Yes. So I have to sub in. Substituting x equals to negative 3 into y, I am going to get negative 8. This is square root of 4, which is 2. I am going to get a negative 16. So my answer is going to be negative 3, negative 16 for the stationary point. Now I need to use part 1's answer to determine the nature of the stationary point. Since we are at d2y dx squared second derivative test, now let me use d2y dx squared to find the nature of the stationary point, whether it is going to be maximum or minimum point. Okay, over here I hope I have enough space. I am going to differentiate this using quotient rule. So I am going to use a ruler, I am going to have to square my denominator. Squaring my denominator, I am now going to copy my denominator. I am going to copy my denominator. I write it as 2x plus 7 to the power of half times the differentiation of the numerator. I have 3x plus 9, so differentiating I have 3, minus copying my numerator, 3x plus 9, and this, I need to differentiate my denominator. Okay, here goes. This is going to be 2 times bring down power half. I have x plus 7 to the power of negative half. Steady. So now I am going to differentiate, I mean simplify, and I want to factorize out my x to the power. I am going to factorize x plus 7 to the power of negative half. So what is left? First part, I have 2 times 3, which is 6, and I need to make sure I have x plus 7 to the power of 1. Minus, good job for us, 2.5 is being cancelled away. So we are going to have, this is factorized out completely, so I have 3x plus 9 left. Now I have to make sure I take good care of this negative sign when I open up the brackets. So now I am going to open up the brackets, and this is what I am going to get. I am going to get, okay, I am going to get x plus 7 to the power of half. And I notice that they are the same, x plus 7, x plus 7. So this one can be combined to the denominator. I am getting 4 times of x plus 7. Power 1 plus power half is 3 over 2 at the denominator. Numerator, I'm going to get 6x plus 42 minus 3x minus 9, which is going to be 3x plus 33 over, let me write this in square root form. Square root of x plus 7 whole thing cubed. So now let us determine the nature when x equals to negative 3, right? When x is equals to negative 3, let me substitute this into d2y dx squared. I am going to get 3 times negative 3 plus 33 is equals to 4 square root of negative 3 plus 7 whole thing cubed. I'm so grateful that I have negative 3 plus 7 because it is